Hello dear students, your Saurin sir is back again to talk regarding the sulphonation reaction of benzene and its second part. If you remember in the previous episode, we considered the electrophilic substitution reaction of benzene and especially the sulphonation reaction, and there we had undergone with preparation of benzene sulphonic acid, and from there we had taken the preparation of phenol. The second half of the reaction we'll take in this episode. We'll start with benzene sulphonic acid. In short, you can also write BSA. Fine. So we had prepared BSA in the last episode. Now we are proceeding from BSA. I am performing the same sulphonation reaction, and for BSA this time, not for benzene, because we are one step. Already we have cleared one step. So as you know, again you can go with concentrated sulfuric acid and SO3 gas, or you can also go with concentrated sulfuric acid and concentrated sulfuric acid 2 moles. Either or, both the theories we have undergone in the previous session. As we perform sulphonation on benzene sulphonic acid, this time we need to keep one thing in mind which we had discussed during the nitration reaction of benzene, and that was regarding the position ortho, meta and para. Here the group is SO3H, which is already present on benzene. So you can see when group SO3H is present on benzene, it has got the directive effect. It is now the directing group. It will direct the incoming group according to its wish and will. Here SO3H group is electron deficient group. It is electron withdrawing group, and as a result it will have a tendency to direct any damn incoming group only and only at the meta position. No other position except meta. So that should be very much clear to you. Now as far as this reagent is concerned, you know very well, we talked for the mechanism in earlier all the reactions. SO3H plus will be again formed when the reaction takes place for sulphonation. SO3H plus and electrophile, that is sulfonium ion. Existing SO3H will direct the incoming SO3H plus onto the meta position because it is an electron withdrawing, electron deficient group. So here SO3H, which is a meta directing group. Now you can see with respect to SO3H, this carbon position or this carbon position are the same. Means if this is carbon 1, then this is second and this is third. On the right hand side you can see if this is carbon 1, this is second and this is third. So either on right hand side or left hand side, any one side at a time you can post, you can substitute the SO3H plus group on that particular carbon atom. So here the SO3H plus, that is sulfonium ion, will attack the meta position as the group SO3H will direct that group that is there. So the incoming group is SO3H with plus sign, attacks the carbon. But if you remember in the earlier discussion, the H atom present on carbon leaves the carbon, leaving its electron, and as a result this carbon is rich with minus charge. It is rich with electrons, so it is rich with minus charge. So the minus charge of this carbon and plus charge of SO3H gets nullified, and as a result now you can see the SO3H is placed at meta position of BSA, giving you a new compound named as benzene meta benzene. The position with respect to two groups is meta, They are 2 in number, so we write di, and the groups are SO3H, जिसे हम sulphonic acid कहते हैं. So name of the compound is benzene meta disulphonic acid. In short, you can write it as BDS. And obviously, if you take 2 moles of sulfuric acid, as we saw in the previous episode, water will be formed, right? So that is that. The mechanism is the same. If you have just visited the previous episode, you are well aware of. So I am not wasting again your time explaining the same mechanisms which we have explained many a times in the previous episodes. And overall reaction occurs at 200 degree Celsius temperature. It is not over yet. What I am concerned is with one more step. Over here, I want to hit this BDS at a very high temperature, and that too with NaOH, sodium hydroxide. As I heat BDS with NaOH at a very high temperature, the reaction is named, as you can recall the earlier lecture, it's known as fusion. And fusion is performed with NaOH, so it is NaOH I am writing. Fusion means heating at a very high temperature, so we are placing a delta sign. As I perform fusion, I will repeat for you once again. NaOH will ionize into Na plus OH minus. But this time we have 1 and 2 SO3H groups. So compared to the previous episode, this time I'll modify only one point, and that is, instead of taking 1 mole NaOH, I'll take 2 moles of NaOH. Why? Because I need to see that I have got 2 SO3H groups. So mechanism is the same. 2 moles of Na plus and 2 moles of OH minus will be separated from the compound. On the other hand, what happens on BDS? The sulfur group, that is SO3H group, now they are more the sulfur bonded to carbon is more electronegative than the carbon to which it is bonded. So that sulfur pulls the electron from the carbon atom, and as a result both the SO3H group takes away the electron of both the respective carbon atoms. So both those meta position carbon atoms, they are now lacking their electrons, and as a result they are electron deficient. They are not having electron means they are electron deficient. They are having plus sign. So for your simplicity, I'll write over here benzene ring. This carbon and this carbon from which the SO3H groups have left, taking away the electrons, both are having minus signs respectively. Sorry, plus signs respectively. And as a result, the OH minus, 2 OH minus groups with their minus sign attack the carbon from which the SO3H has left the carbon, and those 2 OH minuses combine with the plus sign of carbon, and as a result the compound formed is known as resorcinol. क्या कहते हैं? Resorcinol. So 2 OH groups have substituted 2 SO3H groups. The reaction is not over yet. The 2 SO3H groups which have got eliminated, they have got minus charges, that is there. So SO3H minus 1 and 2 moles, don't worry, they are 2 moles, combined with 2 Na plus, 2 moles Na plus. So Na plus and SO3H minus 1 mole and Na plus SO3H minus 2 moles. So 2 moles of Na, H को यहाँ पे substitute करते हैं, interchange करते हैं, forms 2 moles NaHSO3 as byproduct. And so the compound is known as sodium bisulfite or sodium hydrogen sulfide, which is a byproduct. So you will get resorcinol from benzene sulphonic acid, and this benzene sulphonic acid is obtained from benzene that we learned in the last episode. So this ends the sulphonation reaction of benzene, giving you BSA. From BSA you have BDS, and from there you can generate resorcinol practically. I hope you have understood the later part of the reaction in this episode of sulphonation reaction. And if not, if you have any query, as usual I say, you can have a question on the same episode on the comment section, or you can email me at styrene, styrene 1411@gmail.com. and you are on my channel Saurin.S.Mehta chemistry. So for more topics, more chemistry related orientations, you can click on my posts and you can have your queries solved. So wish you all the very best to understand all these things, and see you soon whenever you want me. Take care.